So let's tackle number 14.7. This is another linear model, and it's kind of fun. It says here that the more you study for a certain exam, the better your performance on it. If you study for 10 hours, your score will be 65%. And if you study for 20 hours, your score will be 95%. Now, of course, the real question is, how do you know that? That would be nice if you could know something like that, and hopefully not so many hours, but whatever. You can get as close as you want to perfect score just by studying long enough. Assume your percentage score is a linear function, so then if you want an 80, how long do you need to study? Okay, so we need to make a linear function. So what that means is that it'll look like, if here's our graph, right? So here's 100%, and this is time. Then you would think that maybe if we didn't study at all, so here's t equals 0, we get maybe a 20% or something. And so the horizontal asymptote would be 100, which means as t goes to infinity, our score, so you'd think our linear model would look something like this, right? Closer and closer and closer to 100 the longer we study. So if you want an 80, which is maybe right here, you go across and you say, oh, we have to study this long, right? So we want to find what this graph is here. Now, studying less than 0 hours is kind of meaningless, right? We want to start at 0. So this is what we think our graph would look like, something like that. Okay, so let's plug in the numbers. Now, the nice thing is, again, we know the horizontal asymptote. That's the number it approaches is 100. So we know that A is equal to 100, and we want something, and I'm going to use t for x, so f of t is equal to at plus b divided by t plus c, again just using t instead of x for time, and we know that a is 100 because that's the horizontal asymptote. As t gets super big, these numbers don't matter anymore. T cancels out the t above, we get a, right? Okay, so really now we know that f of t is equal to 100t plus b divided by t plus c. Now our job is to find b and c, and that means we need 2 points. So we can have 2 equations and 2 unknowns, and of course they give us 2 points. They say if you get a 65% if you study for 10 hours. So our first equation is 65 equals, let's see, t is 10. So 100 times 10 plus b over 10 plus c, which that's just 1,000, of course. And our other equation is we get a 95 if we study for 20 hours. So a 95 we study for 20, so that'd be 100 times 20 plus b divided by 20 plus c. Okay, let's multiply these out. It's always easiest to just take the bottom here, cross multiply, kind of multiply it over here to get rid of the denominator. 10 times 65 is 650. C times 65 is 65. C equals 1,000 plus B. And over here we have 20 times 95. It gets tricky to do in your head. I think that's 1,900. 2 times, yeah, I think that's right. So 1,900 plus 95C equals 20 times 100 is 2,000. 2,000 plus B. And now we can solve for B for both of them. Put the 1,000 over here. So B is equal to, take away 1,000 from 650. I think that's negative 350. Negative 350 plus 65C. And over here, B is left on this side. 1,900 minus the 2,000 is negative 100. So negative 100 plus 95C. If they give us the horizontal asymptote, you can always easily solve for B like this. Now we just set those two things equal. So we have negative 350 plus 65C is equal to negative 100 plus 95C. Let's see. This C is bigger, so let's take away 65 on this side to keep our C positive, just because that's kind of nice. So 95 minus 65 is 30. Add the 100 to here. So negative 350 plus 100 is negative 250. So C then is negative 250 divided by 30. So C is negative 250 divided by 30. That's not going to be pretty, so let's just leave it as, take away the zeros, negative 25 over 3. It's too bad it's not a nice whole number, but we'll just leave it as a fraction. It's good to leave things as fractions, not decimals, because then you got to round off. So we'll just keep that as a fraction. Okay, that's our C. So I'm going to circle that so remember it. Now we want B, and I can use either one of these earlier equations for B. Let's use this one. So B is negative 100 plus 95 times C. C is negative 25 over 3. Okay, that's not going to be pretty either. Let's change this all to thirds. Negative 100 is negative 300 over 3, right? Negative 300 by 3 is negative 100. That's right. 95 times negative 25 is some horrible number. 95 times 25 is 2375. It's negative, so minus 2375 over 3. Keeping this as thirds then. Negative 300, so that's what, negative, add 300 to that, negative 2675 over 3, and we'll just leave it as a fraction again. So that's what our B is. Now we can write out our equation since we know A is 100. So finally, our grade, the grade, which is our function of t, is A, which is 100t, plus B, which is negative, minus 2675 over 3, divided by t plus C, and C is negative 25 over 3, so that's negative 2. Alright, there's our grade. Now we can plug in any t we want. If we plug in a certain amount of time, we can figure out what grade we get, or if we know our grade, we can figure out how much time, which is more work, and of course that's what they give us to figure out. And that'd be easy. Again, if they say, if you study for 1 hour, what kind of grade do you get? Well, you just plug in 1 for t, 100 minus that, you gotta do fractions, but they don't make it easy on us. They say we want a score of 80%, how long do we gotta study? So we plug in 80 here, so 80, and we gotta solve for t, 100t minus 2675 over 3, divided by t minus 25 over 3, but it's not too bad. Again, we want to get rid of fractions, so multiply this on this side, so we get 80 times t, so 80t, minus 80 times this, what's 80 times 25? 80 times 25 is 2000, so minus 2000 over 3 equals just the top, 100t minus 2675 over 3. Let's put the t's over here. Let's put the t's over here because it's positive. So we get, excuse me, 100 minus 80 is 20t equals negative 2000 plus 2675. The 2675 wins because we're going to add this over here by 675. So you can check this, but I think it's 675 over 3. Check that again. Negative 2000 plus 2675, 2675 minus, yep, that's right. Or divide both sides by 20 here. So then t is equal to 675 over, put the 20 next to 3 here, 3 times 20, which is 675 divided by 60. I'm just going to do that in my calculator. 675 divided by 60, which is 11.25. And let's see, we're talking about hours, so if you want an 80%, you got to study for 11.25 hours. All right, pretty cool. So this is our model again, our linear model, which, you know, maybe it kind of makes sense. That grade studying could go like that. This one's a lot of hours studying, but maybe it's a final exam or something. But again, it kind of makes sense. You don't study at all. You know something, you'll do okay. And as you study, you can get closer and closer to perfect score, but there's always that super hard question you can never get or something. Now, what does our model actually work? Now, when does our model blow up? And they're saying at t equals 25 over 3, right? Then this thing goes to infinity. We divide by 0. 25 over 3 is about 8. So actually they're saying at t equal 8, which is, I don't know. We know that actually t equals 10, we get 65, so 8's right here. That's our vertical asymptote. So actually their model looks like this, not like the one that I drew earlier, which kind of made sense, where 0 hours you get a score. Their model looks like this. The vertical asymptote's here, and it goes up like that. In other words, if you study for somewhere around 8 hours, you get a 0. You get nothing. You got to study for at least 8 hours to even get a score. And then after that it goes up. Which, I don't know, maybe there's a test like that. Not very realistic for this model to be true. Kind of down here, it doesn't really make sense. Maybe it starts making sense way up here. But not a very realistic model here. Because, again, studying 0 hours really, or you can't even study 0 hours. It's not possible. The least you can study is this horizontal asymptote, which is a little over 8 hours. So, yeah, anyway. So the model isn't perfectly sensible, but maybe it makes sense in the top end. All right, that's number 14.7. Again, linear to linear models. You know, again, they can make sense if you only look at part of it. But that's how you do it. Hope that helped.